students, good evening. Welcome to another video of Vedantu Karnataka. This is Catherine, your physics master teacher. Quickly, can you let me know if I am audible and visible? Good evening. Welcome to another video of Vedantu Karnataka. Today I think my audio is fine, right? Last class my audio wasn't that great. And some of you were telling me my audio wasn't good. Can you let me know if today my audio and video are both good? Yeah? Why isn't anybody talking in the chat? Can I have some highs? Hello, hello. Good. Okay, audio is good. Thank you so much, Tejasri. Hi, Tejasri. Others. So last class we looked at 2 markers. Today we're going to look at 3 markers. So we will be looking at all the 3 markers from past year papers and the NCRT and the questions that are suggested by the board. Okay. So all these questions from chapter 1 units all the way till gravitation we'll do in today's class. Okay. Hello Meenakshi, welcome to the lesson. Where is everybody? Can you all quickly send this link to all your friends? Quickly. Send the link to all your friends so we can all solve together. Okay. Shall we start? Are you all ready to start with chapter 1, units and measurements? If you're all ready, put some fire emojis in the chat quickly. Hey, what is this symbol? Okay. If you are all ready to do 3 markers with me, quickly put some fire emojis in the chat. Yes, let's have some fire emojis in the chat. Quickly. Okay. So first question is from the chapter Units and Measurements. Let's look at the question. Question number 1. Question number 1. Check the dimensional correctness of the equation x is equal to ut plus half at square. Oh, this w has to be here where the symbols have their usual meaning. Okay? So question is, check the dimensional correctness of the equation. How do you check if an equation is dimensionally correct? It's very easy. You just have to check if the dimensions on the left hand side is equal to the dimensions on the right hand side. So for example, x stands for length. What is the dimension of length? L. Okay? So this will be L equals. What is the dimension for u? The dimension for u stands for velocity, initial velocity. The dimension for velocity is distance by time. So L by t, L t raised to minus 1. Good evening, Preeti. Welcome to the lesson. Okay. So here instead of u, I will write L t raised to minus 1 into t. What is the dimension of t? T itself plus half is a constant. Constants do not have dimension. So you ignore half. What is the dimension for acceleration? Acceleration is velocity by time. So the dimension for velocity is L t raised to minus 1 divided by time will be L t raised to minus 2 into t square has the dimension t square itself. Okay? Guru Raj, good evening. All of you quickly send this link to all your classmates, all your friends. Ask all of them to join. So yeah, now let's do it. T raised to minus, this will become what? L is equal to T raised to minus 1 into T cancels. L plus T raised to minus 2 into T square. This is basically, T raised to minus 2 plus T, which is T raised to 0. It will cancel. So plus L. So you can see that here the left side has dimension L, the right side also has dimension L. So you can say that the equation is dimensionally correct because LHS is equal to RHS. Now, so for people who don't understand my handwriting, I've typed out the answer as well. You can look at that as well. Okay, so you might not get the same equation. You might get a different equation and they might ask you to find out the correctness. So what you have to do is you have to find out the dimensions for all the terms on the left side and the right side and make sure they are the same. That's all. Easy peasy. Okay? Yes, all those who understood this, put some fire emojis in the chat. Let's make the class live, students. This is a live class. It should be lively, no? Yeah? Can I have something in the chat? All of you put some fire emojis in the chat. Quickly. Next question. Check the dimensional correctness of the equation. T is equal to 2 pi root of L by G. Similar question. So we have to check if the dimension is correct. So let's do it. So the equation is T is equal to 2 pi square root of L by G. Now 2 pi does not have dimensions, so we'll ignore it. Okay? Root. So we'll just take out the dimensions of the terms that we have. T has a dimension, T itself, because it represents time. L is what? L is length. Length has a dimension, L itself, divided by gravity is what? Acceleration due to gravity. So gravity and acceleration due to gravity have the same dimension, which is velocity by time, L t raised to minus 2. L and L will cancel. This will become t square. So you might be wondering, ma'am, t is equal to t square. The equation is not dimensionally correct. But it's not t square. It is square root. Square root. So then what do we get? We will get t is equal to t. So then you can say that both sides of the equation have dimension t. So the equation is dimensionally correct. So students, you have to write this one sentence. Okay. In your answers, you have to write this one sentence. Very important. Alright. So this 2 pi we don't take because constants do not have dimension. We take the dimension for t and then root of L by G. Okay. Any doubts here? Any doubts? Quickly, let me know in the chats. A Friday evening, has everybody gone to party? There's very few students in class. I think Friday evenings are not a good time to study because next is weekend, no? Hello, Chinese world. Where were you? I missed you. Welcome to the lesson. Go invite all your friends to class. Okay, let's look at the next question. So we looked at 2 questions to derive correctness. Next question. Derive expression for period of simple pendulum which depends on length, okay, and acceleration due to gravity G using dimensional analysis. Okay. So you will have so many questions like this where you have to derive an expression using dimension. Okay. How do you do that? How do you derive expression using dimension? I'll teach you. Okay. So first thing, whatever equation you get. Okay. So you have to derive an expression for period. So you have to derive an expression for time period that is given to us. So we'll write it in a general formula. Time period is equal to, let's say there's some constant k. Okay. For any equation, whatever it is. For here it is time period. Time period is equal to, I'll just put constant k. What else? It depends on length. Okay. It also depends on gravity. Now, I don't know if it depends on square root of L or L square or L cube or L raised to 4. I don't know that. So, I'll just put it as L raised to A. Similarly, I don't know if it is square root of G or G square or G cube. So, I will put it as G raised to B. General formula. Okay? Yes? General formula? That's okay, Shini's well. I was just joking, okay? Yeah? Hi, Savio Jos. Welcome to the lesson. Okay. Yeah, so we'll just generally write it as T is equal to K, L raised to A, G raised to B. Next, what we will do, we will write down the dimensions for all this. Okay? So, what is the dimension for time period? The dimension for time period is T itself is equal to, K is a constant, I'm going to ignore it. The dimension for L is length. So, L itself, L raised to A. Okay? Now, what is the dimension for gravity? Yes, very good, Chinese word. The dimension for gravity is the dimension for acceleration due to gravity. What is the dimension for acceleration? L t raised to minus 2 times b. So, this is my dimensional formula. Okay. Now, what I'm going to do is I am going to equate the powers. Okay. How will I do that? So, here L has a power of 0. I'll write that also so it's clear to you. So here L has a power of 0 because there is no L. Okay. So let's equate for L first. So equating for L. So on the left side it's 0 is equal to, on the right side we have A plus B. For the first term, L raised to A, so A. And then second term, L raised to B, so B. So from this, I will get A plus B. Okay, let's just put it as A 0 is 0 equals A plus B. And then we'll equate it. Next, equating for T. Equating for T. So what is the power of T on one side? It's 1 equals minus 2 into B. So from this, I can write B equals minus 1 by 2. I can do that. Yeah. Now what I will do is I will substitute that here. So this is basically A minus 1 by 2 equals 0. So I will get this as A equals 1 by 2. Okay. Now what I will do? I will substitute that here. So instead of L raised to A, I'll write L raised to 1 by 2. Okay, let me just substitute it in my equation. Yeah, I'll substitute it here. So this is K times L raised to A is what? 1 by 2. G times B raised to minus 1 by 2. Now, what is anything raised to 1 by 2 is obviously square root. Yeah. So, this can I write it as L raised to 1 by 2 divided by G raised to 1 by 2? Yeah. Okay. Now, this will be K times square root of L by G. Okay. So, now my formula is T equals K times square root of L by G. Okay. T is also proportional to square root of L by G. Okay. Now we already know, you have learned this formula, so you know that K is what? 2 pi. So you can say this is equal to 2 pi square root of L by G. Okay. So I've already typed out the answer there. So for those of you who understand that, you can look at that. Who have understood what I've written, you can look at that as well. Oh, I'm really sorry, Chinni. I'll call you Chinni from now on, okay? It's clear, Guru Raj? Okay. Yes, very good, very good. Yeah. Are you able to see because of my head? Okay. So these are the steps. Very easy, no? This red part is the final part. Okay. I just wrote it there, but it's in the order. First the blue, then the red. You can just follow the video. Okay. Clear, ma'am. Okay. Let's move on to the next question then. Okay, one chapter is done. One chapter is done. So for units and measurements, usually 3 markers only come from dimension. Okay. Either it will be to check the correctness or to derive formula using dimension. Okay. Those are the only 3 markers that you usually get. Either to check correctness or to check dimension. Okay. Okay. Next chapter, motion in a straight line. Are you all ready to learn motion in a straight line? Okay, so for motion in a straight line, let's look at the first question. Derive the expression v equals u plus at or v equals v naught plus at using a velocity time graph. I put an or because sometimes your question paper will have u, sometimes it will have v naught. You should know it's the same thing. Okay, v naught is equal to u is equal to initial velocity. Okay, v naught and u both are the same. So even if you get this equation or this equation, you should know it's the same thing. Okay. Hey, there's a mistake here. This shouldn't be here. Okay. This is not the answer to this one. Erase that. I will not be able to erase it here. No? I can do something. What can I do? I can put a text box. Hey. Sorry. I don't see feeling. Okay. Anyways. Physics is 13th. Okay. Yeah, let's anyways do it here. That didn't work. So I will do it here. So question is derive v equals u plus at by a velocity time graph. Okay. So let's do that. Very easy. First thing what you need is you need to have the graph. Yeah, because you have to derive from the graph. So I'll draw the graph. Okay. Yeah. So I'll draw the graph. So on the graph, what do I have? I have time, t, on the x-axis. Okay. Sorry, something else. Okay. And then velocity v on the y-axis. Okay. Now what am I going to consider? I have a body. Let's say it's a car. Okay. Let's say it's a red car. In this red car is initially at rest. I'm not moving. Now after some time, I start moving with a velocity which is uniform. So this is the motion. Okay. So this much is what? This much is my initial velocity. Okay. From here, this whole thing. Yeah. This is my final velocity. Okay. Initial velocity and final velocity. Now what to do? I will just derive the formula. So what I will do is I will find out the slope of the graph. Okay. So what is the slope of the graph? If I take this point is what? V and T. This point is what? U and 0. So slope of the graph is basically change in velocity divided by change in time. Initially time is 0, so t minus 0. So this is v minus u by t or v minus v naught by t. Okay. But we already have learned that the slope of a velocity time graph gives you acceleration. So acceleration is equal to v minus u by t. Very easy. Easy, no? Yeah. Okay. Easy, right? Very easy. Okay. Now let's move on to the next question. What is the next question? This question. Next question is, derive the expression V square is equal to V naught square. Chinni is all putting all the answers. Very good, Chinni. Okay. Derive the expression V square equals V naught square plus 2ax using a velocity time graph. Okay. So here it's V naught square. It could be V square as well. It really does not matter. Alright. Okay, let's do it. Are you all ready to do it? Yes, yes, no. Okay, so here what we're going to do is, first we're going to take this whole figure. So first what I'll do is, easy peasy, yeah. First what we'll do is, I'll take this whole thing. So this is basically a square and a rectangle. Some people say it's a trapezium, okay. However you want to, you can do it, okay. You can either take it as a square and a rectangle. Find the area of the, a rectangle and a triangle. Oh my god, what am I saying? A rectangle and a triangle, okay. Find the area of the rectangle plus the area of the triangle and then solve it. Or you can take it as a whole trapezium. So here I'm going to take it as a trapezium, okay. So I will take the area under the graph. What does the area under a velocity time graph give? Area under velocity time graph gives? Very good, displacement. So I will take x is equal to, now I'll find out the area under the graph. So for a trapezium, the formula is half times both the parallel sides into the base. So the first parallel side is what? V. Okay. The second parallel side is a small one, which is U or V naught. I'll just put it as V naught. This is V naught or U. Okay. V naught into the base is time. So this is the formula for a trapezium. So one parallel side is this, the second parallel side is this, and the base is this. Half into parallel side by base. Okay. You can also take it as area of triangle plus area of rectangle. No issues. Okay. You can take it that way also. Alright. So this is the first step. And then what am I going to do? I already know that from first equation, I know that acceleration is equal to v minus v naught by t. So t is equal to v minus v naught by a. Yeah. Confusingly, Shivu. What is confusing here? Very easy, no? What is the confusion here? From first equation, you know t is equal to v minus v naught by a. Okay. Now what I'll do, I'll substitute that. So x will be equal to half into v plus v naught times v minus v naught by a. Okay. Yes. Now I'll just take a outside. So this will become x is equal to 1 by 2a v plus v naught times v minus v naught. Okay. Now a plus b into a minus b is a square minus b square. Yeah. A plus b into a minus b is equal to a square minus b square. So x is equal to, okay, x is equal to 1 by 2a v. This is live, Shivu. This is live. Okay. So this will be v square minus v naught square. Now what I'll do, I'll just cross multiply. So 2ax is equal to v naught square minus v square minus v naught square. So 2ax plus v naught square is equal to v square. Okay. This is the equation. Now, if you're not understanding what I've written, you can also look at this typed version. Both of it will give you the same thing. Okay, so very easy. I don't know what's the confusion part here, Shiv. The only thing is there are two parallel lines. I mean, you take the whole area under the graph as a trapezium. The area of a trapezium is half times the two parallel sides into the base. And then instead of time, you substitute the first equation. Acceleration is equal to v minus v naught by t. You substitute that in terms of t. And then simple math. Okay? Okay, let's move on to the next question. Okay, Chini. Hi, Manoj. Mention 3 applications of a velocity time graph. So we already looked at these things. For a velocity time graph, one thing we already know. If you find out the slope, you get the acceleration. If you find out the area under the graph, you get displacement. And it helps us understand the motion. You can say if it's uniform acceleration or non-uniform acceleration or steady speed or the body is at rest. All these things you can study from a velocity time graph. Okay? It helps us analyze the nature of motion. Very easy, 3 things. Okay? First thing, it gives acceleration. Area under the graph gives displacement and it helps predict nature of motion. Okay? Thank you, Guru Raj. Next question. A car moving along a straight road. Okay? So there's a straight road and then there's a car. Okay? There's a car moving along the straight road. And the speed of the car is 126 kilometers per hour. It is brought to stop within a distance of 200 meters. What is the retardation of the car? So retardation is similar to acceleration. Retardation and acceleration, same thing. So let's find out acceleration, then we'll convert it into retardation. So what is one formula that we know that connects acceleration, velocity and displacement? Sorry. That is v square is equal to u square plus 2as. Okay. Now, see, the car was going fast and then it hit and it stopped. I mean, it stopped somehow. So, final velocity is what? It stopped. So, final velocity is 0. So, you can say 0 square is equal to initial velocity is how much? 126 kilometers per hour. So I'll have to convert it. How do I convert it? 126 into 5 by 18, which is 35 meters per second. Okay. So 0 square is equal to 35 square plus 2 into acceleration into displacement is 200. So from this, 0 is equal to 1225 plus 400 into acceleration. And simple calculation, I'll take it to the other side. So I'll get 400 into acceleration is equal to minus 1225. So acceleration will be minus 3.06. Now, the question is retardation. So if acceleration is minus 3.06, then retardation is plus 3.06 meter per second square. Okay. Yes. Retardation and acceleration are not the same. If acceleration is negative, then retardation is positive. So what I did is I found out acceleration because I don't know a formula for retardation. So I find out the acceleration and in the last step, I just switch signs. So I got my acceleration as minus 3.06. I converted into retardation by making it positive. That's all. Yeah. Easy, no? For 3 mark and all, you'll have easy questions only. Okay. Yes, very good, Guru Raj. Very good, Chinni. So v square is equal to u square plus 2as. Any doubts here? Any doubts? Students, for 3 markers and 2 markers, if you get numericals, please do attempt them. They'll be easy questions only. Okay. Please do attempt them. You'll definitely get all the 2 marks. Next question. 2 or 3 marks. Okay, a stone is thrown vertically upward. Okay, so there's a stone that's thrown upwards with a velocity of 20 meters per second. Calculate the maximum height reached by it. So we have to calculate the maximum height. Okay. So again, the only formula relating acceleration, velocity and displacement is v square is equal to u square plus 2as. V square is equal to u square plus 2as. So students, think about it. What is happening here? A person is throwing a stone up. Yeah. We have to calculate the maximum height reached by the stone. So when I'm throwing it with a velocity of 20. So my initial velocity with which I'm throwing it is 20. So it's going to go up, be at a point and then come down. So that one point is where the stone will be at rest, like for very few milliseconds. So at that particular point, it has no velocity. It's going to go up, stay there, come down. It's very fast. You will not be able to see it, but it's going to stay there for some time. So final velocity when it reaches up is going to be 0. So 0 is equal to 20 square plus 2 times, it's going against gravity, so I should take minus 10 times height, I don't know. Now, simple math, you will just solve it, you will get 0 is equal to 400 minus 20h. So when you solve it, you will get h as 20. Okay. Maximum height h is u square by 2g also. Okay, Shivu. But what will you take u as? What is u here? Okay. Is this clear? Alright, any doubts? Okay, if you do that formula also, you should be getting the same answer. Okay. Whichever formula you use, students, you should be getting the same answer. Yeah. In any formula with the same parameters where you can put u, g and h, you should be getting the same answer. Shiva, you can try with that formula. You will definitely get 20 itself. Okay. Because you're finding out the same thing. You will get 20. Okay. So for others, Shiva also told us that there's a formula. H is equal to u square by 2g. Even if you use that formula, you should get 20. Okay? Okay, Gururaj. So those are the questions from the chapter Motion in a... No, this chapter was the second chapter. So we had questions related to finding equations of motion from the graph and then numerical questions and some theoretical questions. Okay? Now let's move on to the next chapter, which is motion in a plane. First question from motion in a plane. Yeah, Shiv got 20. See, I said you'll get 20 only. See, for every numerical question, there's no one formula that you should use. You can use any formula that will give you the answer and that suits that equation. Okay, I just used formulas that we just derived. So then there's no confusion for students. That's all. Okay. Okay. Next is motion in a plane. First question. Explain the triangle method of vector addition. So in the triangle method, we have two vectors. Okay. Let's say there's vector A and then there's vector B. Alright. What I'm going to do is I am going to make them two sides of a triangle. So if I have to do A plus B, I'll take A as the base and B I'll draw like this. So the head of A and the tail of B should be in contact. Okay? Okay, so if this is vector A, head of the arrow is the head of vector A and tail of vector B should be in contact. Alright? Yeah? So the tail of the second vector should be at the head of the first vector. Understood? Tail of the second vector should be at the head of the first. So this is first, this is second. So it should be going like this. Okay? Now, the resultant vector should be drawn from the tail of the first vector, which is A, tail of the first vector, to head of the second vector. This is the resultant. Okay, so this is triangle method of vector addition. Now imagine if I have to do B plus A. Okay, if I have to do B plus A, then I should put B first. B plus A will be R. Okay, so the order is important. So my diagram is for A plus B. Okay, any doubts for triangle law? Okay, next question. If A equals, so if A equals 3i cap plus 2j cap and B equals I minus 2j plus 3k. Find A plus B. So this is also very easy, students. To find A plus B, what you should do is you should take the components of I and j and k together. So A plus B will be, first I'll take the I components. So 3 plus 1 I cap plus 2 minus 2j cap plus 0 plus 3 k cap. So this will be 3 plus 1 4 I cap plus 2 minus 2 0 j cap plus 3 k cap. Okay. Now to find out the magnitude, what I will do? To find out the magnitude, I'll take the square root. Square root of first term is 4. So 4 square plus 0 square plus 3 square. So this is going to be square root of 16 plus 9, which is square root of 25, which you will get 5. I've solved it here. Okay. Even if you get different numbers, you should be able to do it. Easy, no? Take I cap terms together, add them, j cap terms, add them, k cap terms, add them. Magnitude is I cap terms square plus j cap terms square plus k cap terms square, square root of the whole thing. Alright, next question. Two forces of 4 newtons and 3 newtons act at a point making an angle of 60 degrees with one another. Find the magnitude of the resultant force. So here, this is 4 newton. This is 3 newton and they make an angle of 60 degree. Okay, 4 newton, 3 newton make an angle of 60 degree. So resultant is what? 4 square plus 3 square plus 2 into 4 into 3. 2 times 4 times 3 cos 60. I've already solved it here. Okay, 16 plus 9 into 24 times 0.5, you will get square root of 37, which is approximately 6.08. Okay? Yeah. So the formula is R is equal to square root of A square plus B square plus 2AB cos theta. Okay, next question. Obtain an expression for time of flight of a projectile motion. So for projectile motion, first thing you need to know, this is how it is. Yeah. This is how it is. This is your theta. So, this is u sine theta and on this side we have u cos theta. Okay. So, the time taken to reach maximum height is when projectile goes like this. So, the time taken to reach maximum height. Okay. So, that is when your vertical velocity, your vertical velocity becomes 0. So at the maximum height, vertical velocity is 0. So what will you get? So you will get final velocity is 0. Initial velocity is what? Initially it's going up with the velocity of u sine theta minus acceleration is what? The formula is v is equal to v minus u by t is equal to a. So from this I will get v is equal to at plus u or u plus at. Why am I writing all this? I'll just write down the final formula. V is equal to u plus at is our formula. Okay, v is 0 because for a projectile from here It goes, when it reaches the top, velocity, vertical velocity is 0. See, from here, it's coming, it's going up, 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 up. From here, it's no longer going up, it's going this side. So it will have horizontal velocity, but no more vertical velocity. So vertical velocity is what we are finding, because we are going to find out the time of flight. So 0 is equal to vertical velocity initially is u sine theta. Now acceleration, you are going against gravity because you are going up. So acceleration will be minus g. That is why this becomes minus g into t. So from this, u sine theta is equal to gt. T is equal to u sine theta by g. Now this is for halfway. From here it lifts, it goes up till here. Now what happens? It comes down. So same time it takes. So the total time will be 2 into t. Okay. What we just found out is the time from the base till here. From here till here, it's again another t. So 2t will be 2u sine theta by g. And this will be a capital letter T. Okay. Okay. Next question. Obtain the expression for maximum height of a projectile. So for maximum height of a projectile, what are we going to take? Height is along y-axis. So again, we'll take the same formula. Manyasri, this is only 3 markers. Okay, you can score full for 3 markers. Okay, I have already done a video on 2 markers. I will be doing videos on 5 markers and problems, numericals. Okay. So maximum height is along y-axis. So we'll take vy square is equal to uy square minus 2gh. Y minus g is going up. That's why. Okay. So uy square is what? Along y-axis. Velocity is what? U sine theta. As I said, when it reaches the top, it is 0. So you will get u sine theta square minus 2gh. H is the height. So from this, I can write 2gh is equal to u square sine square theta. So h is equal to u square sine square theta by 2g. Yeah. Yes. So students, I want you to understand this. So this is how the projectile is. It's going up. So when it's going up, velocity is u sine theta. Now how do I know that? See, this is theta. This is the angle of the projectile. Every time the line close to the angle will be cos theta. So here you are looking for initial velocity. So u cos theta. The line away will always be u sine theta. Okay. U sine theta. So it's going up. So you should take u sine theta. And when it reaches the top, it is no longer going up. So vertically, final velocity will be 0. That is how this is 0. Okay. Yeah. Okay. Next question. A projectile is projected at an angle of 30 degree. So that means this angle is 30 degree. Okay. So we have to find out the time of flight. We already know the formula. T is equal to 2u sine theta by g. Okay. Initial is, so 2 into 20 sine 30 by g is 10. If you do the math, you will get the answer. You will get 2 seconds. Okay. Yes, sure, Manyasri. I am doing all past year papers and all questions suggested from the board. Okay. So if you practice every question and learn it properly, you will definitely score very well. But you should practice 2 markers, 3 markers, 5 markers, numericals and MCQs. Okay. Hi, Mr. G. Welcome to the lesson. Yes, Guru Raj. U is 20. Very good. Can you tell me what is time of flight? Can you quickly find out the answer? Okay, next question. Obtain the expression for horizontal range of a projectile motion. Horizontal range is what? Along x-axis. Okay. So for horizontal range, what I'm going to take is r is equal to initial velocity along x-axis into time of flight. So u cos theta into t. T we already found out. Then you will get the final answer. Previously Previously, I was doing vertical component. Now I am doing horizontal component. Horizontal component is along x-axis. Initial velocity is u cos theta. Total time is t. So u cos theta into t will be your answer. Okay. Next question. A stone of mass 2 kg is tied with a string of length 1.5 meter. Very good, Gurraj. Is rotating in a circle with constant speed. Calculate centripetal acceleration. Centripetal acceleration we already know it's v square by r. Yeah. What is velocity? 10. And r is the length. So if this is rotating like this, to find centripetal acceleration, I need to take how fast it's rotating and the length. Okay, length is 1.5. So 10 square by 1.5, you should get 66.67. Okay, can you all quickly let me know in the chat if you're getting 66.6? Okay, let's move on to the next chapter, laws of motion. First question from laws of motion. mv square by r is centripetal force, Gururaj. Centripetal force is mv square by r. But we know force is mass into acceleration from Newton's second law. So I will write force as mass into acceleration, which is mv square by r. So m and m will cancel and we'll get acceleration is equal to v square by r. Okay? Okay. Next is laws of motion. Fourth chapter, laws of motion. Few more chapters to go. First question. Write Galileo's experimental observations of motion of objects on a single inclined plane. So what did Galileo say? On a single inclined plane. So first thing, Galileo observed that if you have a ball rolling on an inclined plane, it acquires speed and covers equal distance in equal intervals of time. Yeah. Now when the incline is reduced, acceleration decreases. So let's say initially this is the incline. There's a body going. So this body covers equal distance in equal intervals of time. Now when the incline is reduced, I reduce the incline, it goes slower. Acceleration decreases. Now if the incline is horizontal, what will happen? The ball will move with uniform velocity. Okay? Yes. Now when the ball rolls up an incline, what will happen? If this was all for balls coming down. If the ball is going up, even after some time it will slow down and it will come back because of gravity. Okay? These are the different laws. Alright, next question. Explain inertia of rest, inertia of motion and inertia of direction with examples for each. First one, inertia of rest is the tendency of a body to remain at rest unless and until an external force acts on it. Simple example, book on a table. Okay, a book on a table will remain on the table forever unless and until it is pushed. Next one, for inertia of motion, what will you write? So, inertia of motion is the tendency of a body to continue moving with constant velocity unless an external force acts on it. For example, if I roll a ball, this rolling ball will continue to roll forever. What stops the ball? Friction stops the ball. Otherwise, it will continue to roll forever. Next one, inertia of direction. What is inertia of direction? The tendency of an object to resist any change in direction. Okay, so imagine I'm driving. If I'm driving on a straight path, I like to drive on a straight path. I don't want to turn. Okay, if I don't want to turn, that is because I am with inertia of direction. I'm going straight, I'm enjoying it, I want to continue to go straight. Okay? Yes? Okay, next question. Show that the impulse of a force is equal to change in momentum. So I have to show that impulse is equal to change in momentum. What is impulse? This large force at a short interval of time. So if I just punch my hand, I'm applying a large force but for a few seconds. So that is impulse. Impulse is a large force applied for a short interval of time. Now what is force? Force is change in momentum. Instead of mv, I'll write it as change in momentum. change in momentum by change in time. So that I'll substitute here. So instead of force, I'll write change in momentum by change in time into time. This is basically change in momentum. So I can say impulse is equal to change in momentum. Okay? Any doubts here, students? Yeah? Okay? Mm, Guru Raj, more mass, more inertia. Yes, more mass, more inertia. See, inertia is the property of a body to resist any change. So, more mass means more inertia. Okay. See, if there's a sports car going in forward direction and a truck, it's difficult to turn the truck, right, than the sports car. That's because truck is huge. It has huge mass. Okay. Okay. Let's look at the next question. Write the important points to be noted about the Newton's third law of motion with regard to the usage of the terms action and reaction. Okay, so what are the different things with respect to Newton's third law of motion? See, every action has an equal and opposite reaction, which means there's one force in this direction, another force in the opposite direction. So A and B are equal in magnitude, but they're opposite in direction. Okay, and they act on two different bodies and they act together, they act simultaneously. Okay, and they are of the same nature. For example, they could be two contact force or two gravitational force, anything like that. Okay, so that is the answer. Next question. What are concurrent forces? Obtain the condition for the equilibrium of concurrent forces. See, concurrent forces are forces that are simultaneously acting on a single point. Okay, so imagine there are 4-5 forces F1, F2, F3, Fn, and they all act on one point. Okay. Yeah, like your sis beating Newton's third law is like that. You beat, she beats you back. Okay, so concurrent forces are so many forces acting on one point. Okay, so which means if you just add all the forces together, you will get 0. Okay. Hi Shivani, welcome to the lesson. Next question. Next question. State the laws of limiting friction. So limiting friction is what? Limiting friction. Yeah. State the laws of limiting friction. So this is the next question. So what is limiting friction? Limiting friction is basically, it is directly proportional to what? Can someone tell me what is limiting friction? Yeah. What is limiting friction? Okay. So limiting friction is the friction that limits motion. For example, if you have something here, the friction before it slides. So if I have something here, I don't have my mouse today. I have something here, okay? Yeah. So it is a maximum force of friction that acts between this object that I have kept and this base, okay? Before it slides down. So once the downward force overcomes limiting friction, then it can slide. Until and unless it has more force to overcome limiting friction, it won't slide. So one main thing is it is independent of area. So even if I have a big object or a small object, it does not depend. Okay? And it's directly proportional to normal reaction. More normal reaction, more limiting friction. And it acts in the direction opposite to motion. What does that mean? If I have a block here, limiting friction is pushing it up, but then the motion is trying to pull it down. The box wants to move down, but because of limiting friction, it is staying where it is. So limiting friction acts in the opposite direction to the movement of the object. Okay, very good, very good. Does not depend on area. Yes. Next question. State the laws of kinetic friction. Kinetic friction is independent of the velocity. Okay, that is also proportional to normal reaction and it is less than limiting friction. Okay, so what is kinetic friction? Who will tell me what is kinetic friction? Hmm? So, see, limiting friction is before it moves. Kinetic friction is the friction when a body moves. Okay? And yeah, that's all that you need to know. See, all of these things in detail I've done in my lecture series of these chapters. I've done lectures where I've explained all this in detail. Okay? Okay, let's look at the next question. Mention any three advantages of friction, or the question could be friction is an evil, explain. So the main disadvantage is there's a lot of heat going to be produced. See, what is friction? When two things rub against each other. When I rub my hands, what's happening? There's a lot of heat. Same thing happens when friction is applied to different things. Like if you have an engine and two things in the engine rub against, there is heating. Okay? And it can cause wear and tear of moving parts. See, your bike tires or car tires, you have to change them after some time. Why? Because this tire continuously rubs against the road. So there's continuous friction. So what happens after some time? The tire's grip will be lost. Wear and tear will happen. Okay? Friction also causes noise and reduces efficiency of machines. So if you look at your fan, okay, after a long time, when the fan rotates, you'll hear a sound, or your door. When you open it, you'll hear some sound. That is because you have not lubricated. There is friction. Okay? So when there's friction, there is some noise. This can be avoided by lubricating. Yes, these are PYQs as well as questions from the board. Everything mixed together. Yeah? Okay. Next question. Okay, next question is mention any three methods to reduce friction. As I already said, lubricating, polishing. Now, if you use ball bearings, all of this will reduce friction. Next question. Derive an expression for maximum speed of circular motion of a car on a level road. Okay. So this is a level road. Okay. So for a car on a level road, F will be equal to mass into gravity into friction. Okay. That is nu mg. Nu is the coefficient of friction. Mu g is basically the force. Now, it also requires centripetal force, which is mv square by r. So it's moving in a circular path. So to maintain a circular path, mv square by r, which is centripetal force, and the force because of friction should be equal. So this and this should be equal. So that is how you get this equation. From this m and m you cancel. What remains? V is equal to nu gr. So since this is a square, you square root it. Okay? Easy, no? Okay? Any doubts here? See, F is equal to mu mg is, mu is the frictional coefficient and mg gives you the force of friction. So friction should be equal to centripetal force. Okay? Okay, next question. Next question. A body of mass 25 kg moving initially with a speed of 15 brought to stop with an average retardation of 2.5 meter per second square. How long does the body take to stop? Again, let's use equation of motion. V is equal to U plus AT. Now the body is stopping, so V is 0. So 0 is equal to U is what? Initial speed is 15 minus diamond color, ma'am? I didn't understand. 15 minus acceleration is 2.5. I put minus because it's retardation. Okay? Retardation is 2.5, so acceleration will be minus 2.5 into t. So from this I'll get t is 6 seconds. Oh, diamond clear, ma'am, like crystal clear, ma'am. Okay. Okay, Guru Raj. I'm a little old, no? I don't understand your, new generation things. Alright? Is the diamond clear? Yeah? Okay? Why did I take minus 2.5? Because in the question it says retardation 2.5. But I need acceleration. If retardation is 2.5, acceleration will be minus 2.5. Change the color of writing. What color do you want, Shivu? What color do you want? Okay, next question. Constant force acting on a body of mass. Constant force acting on a body of mass. Mass 5 kg. Changes its speed from 4 to 7 in 2 seconds. So initially it's 4. Finally it's 7. The direction of the body remains unchanged. What is the magnitude of force? Okay, obviously, how do I find acceleration? I know F is equal to ma, but acceleration is what? Change in velocity by time. I've done that here. Initial velocity is 4, final velocity is 7, and it takes 2 seconds. It's given here 2 seconds. So I get my acceleration as 1.5 and F is equal to m into a. So 1.5 into mass is 5, 7.5. Direct, straight questions. Straightforward questions. Okay, next question. 2 billiard balls, each of mass 0.05 kilograms, move in opposite directions with speed 6 meters per second and rebound with the same speed. What is the impulse imparted to each ball due to another? Okay. So there are 2 balls, they're moving in opposite directions and they collide and they rebound with the same speed. So 2 balls, one is coming to the right, left, other is going towards the right. They come, they hit and they move with the same speed. Okay. So they come, they hit and then move with the same speed. We have to find out impulse. We already know impulse is what? Impulse is equal to, we've derived a formula. What is impulse? Change in momentum. Yeah? What is change in momentum? Mass into change in velocity. Okay? Yes? Now, what is the change in velocity for the ball? Yeah? 6 plus 6, which is 12. How did I get 12? Because one ball comes and then it hits and then it goes to the other direction. So there is 6 plus 6. 12 meters per second is the total velocity. Mass I already know. I will just multiply it. I will get the impulse. Hi Nathan Kumar. How are you? Alright. Okay. Now at the end I put a negative sign. Why? Because this is velocity, direction is important. Okay. So what happens? It comes and then it's going in another direction. So I will put it as negative. Okay. Next question. A bullet of mass 0.04 kilogram is moving with a speed of 90 meters per second, enters a heavy wooden and is stopped after a distance of 0.6 meters. What is the average resistive force exerted by the block on the bullet? Okay. So we'll take the formula. V square is equal to U square plus 2AS. So it's stopped. So V is obviously 0. Initial velocity is 90. Acceleration is not given. Is it given? Not given. Okay. Speed. No. Distance S is given as 0.6. So let's substitute that. 0 is equal to 90 square plus 2 times acceleration into 0.6. If you do the math, you will get acceleration is equal to minus 6750. But the question is to find out force. So force is what? Mass into acceleration. Okay. Force is mass into acceleration. So mass will be 0.04 into acceleration. You will get 270 newtons. Okay? Yeah? So we are done with questions from chapter 4. Now we'll move on to chapter 5, which is work, energy and power. Okay, we have 3 more chapters, chapter 5, 6 and 7. So I will be back in 5 minutes. Resume back at 8:10. Okay? Okay. Hello, hello. Are we all back? Or was it just me who went for the break? Hello, Shivu. Okay, let's start with the next chapter, which is work, energy, power. Okay, first question. Show that work done is equal to the scalar product of force and displacement vectors. Okay, how will you do that? This I've already taught you when we were doing the work done chapter. Very easy. What is scalar product? F dot D. Okay, so this will be what? F D cos theta. Yeah. So scalar product is the component of force along the displacement and magnitude of displacement. Theta is the angle between the two. Okay. Baswaraj sir's bio live class will be there soon. It was there yesterday. It will be there probably tomorrow or day after or on Monday. You can keep checking the channel. Okay, go to Vedantu Karnataka channel. There are, so many options. Click on live. So if a class is there, it will be scheduled. Okay? Okay? Yeah, that's done. Next question. What is meant by positive work, negative work, and zero work? Give examples of each case. Yeah. So positive work is when force and displacement are in the same direction. So this is the direction of force. This is the direction of displacement. So what is the angle? Uh, the angle between them will be less than 90 degree. Yeah. Then it's positive force. But when they're opposite, so if this is force and this is displacement, and the angle is greater than 90 degree, that is negative. When they're perpendicular, when the angle is 90 degrees, so this is force, this is displacement, then it is zero work. Okay? Okay. You're not able to see it because of my head? Yeah? Okay. Next question. Derive an expression for the work done by a variable force graphically. The half of the question is not there. Graphically, or it could be graphical method. Okay? How will you do that? So, what's a graph? Any random graph. Okay? You just have to have force and displacement and a random graph. And you're going to take a small part of the graph to do your calculation. Okay? So there's a small part that you're going to take. Okay, so this small part is delta x. Now what we are going to do is we are going to find out the work done on that small part. Okay, so a small amount of work is done, which is equal to force into that small displacement. Yeah. Now what is delta? I'm going to integrate the whole thing. I'll integrate both the sides. Integral of delta w is w, which is equal to force times integral of delta x or dx. At the least displacement is 0, maximum is b. Okay. Okay. Next question. Distinguish between conservative and non-conservative force. Give examples for each. This already we discussed for 2 marker. This can come as 3 marker also. So if this is A, this is B. However I reach B, does not matter if it's a conservative force. It is independent of the path. But if it's a conservative force, non-conservative force, then it should follow a certain path. It depends on path. Okay? It depends on the path. Now, If you take a fully closed path, work done is 0 for conservative force because it does not depend on path. So if I take like this, so A and B are the same points, so work done is 0. But for non-conservative, it is not. For conservative, example is gravitational force, non-conservative is frictional force. See, if an apple is on a tree or on the ground, it experiences the same gravity. It does not depend on where the apple is. It does not depend on the path. But look at friction. See, if I'm rubbing like this or if I'm doing this, how I move, my action matters. The path that I take matters. Okay. Yes, Shivu, I'll be taking classes for KCET. NEET, I'm not very sure, but for KCET, this channel, for NEET as well, yeah. Our channel has classes for NEET and KCET. So we will have classes for both. So right now we're focusing on your midterm. Okay. When your KCET exam approaches and NEET exam approaches, we'll be having question practice and rigorous classes for both. Okay. Okay. Next question. State and prove work energy theorem for a constant force. Some of you might be like, ma'am, will this long question come for 3 marks? I've just put all the steps. That's why it looks long. Okay. But it's actually very easy. Let's do it. So what is work done? Force into displacement. Now some of you might be wondering, ma'am, where is the cos theta? Cos theta is what? It is 0 because they are parallel. Force and displacement are in the same direction. So cos 0 is 1. So I will take W as F into S. Now what is F? Newton's second law. F is equal to ma. So instead of F, I will write ma. So ma into S. Now equation of motion will be what? V square is equal to V naught square plus 2as. Okay. So from this, I can write V square minus V naught square by 2 is equal to as. That as, this I can substitute here. Can I do that? So what will my equation be now? My equation will be, oh, sorry. This I can substitute it here. So now my equation will be W is equal to M into, instead of as, I'll write V square minus V naught square by 2. And then simply opening brackets. So W is equal to 1 by 2 M into V square minus V naught square. So this will become 1 by 2 mv square minus 1 by 2 mv naught square, which is what? Kinetic energy final minus kinetic energy initial, which is change in kinetic energy. So W is equal to change in kinetic energy. Yeah, I've put a neat version on this side. What I've derived it on this side. Okay. Yes. Any doubts? On my screen it just looks like my head is there. Can you see me? Or only my head? Okay. Yeah. Is this clear? Any doubts for work energy theorem? Can you let me know in the chats? Is it confusing? Is it clear? Okay. Next question. Derive an expression for gravitational potential energy. Same thing. What will we do? We know Newton's first law. Means second law is equal to F is equal to ma. Now, if the acceleration is only because of gravity, what will I write it as? I'll write it as mg. F is equal to mg. Now, what is work done? Work done is force into displacement. So let's say it moves by h. Displacement I can put any alphabet. I can put s, I can put x, I can put h. So I'll put it as fh. Okay. What is force? mg. So mg h. Okay. Now what I will do? I already know that whatever work is done, it is going to be stored as potential energy. That is one point you need to know, all of you. Okay. Whenever work is done on any body, that work is going to be stored as potential energy. So W can be written as U is equal to mg. Okay. Is it clear? Okay. Is it clear, Shivu? Are you understanding now? Okay? Okay. Next question. Derive the expression for potential energy of a spring. For spring, what is the first formula? Force of a spring is equal to minus kx. K is spring constant, x is extension. Okay? Now what will I do? I will find out work done. Yeah? What is work done? Work done is force into displacement, which is force into, which is, instead of force, I will write this. So I will write that here. I'll write minus kx into displacement will be, I will take it as dx. Okay. I'll take it as dx. Now what I'll do, I'll integrate. Okay. Wait. Yeah. Force F is equal to minus kx. Okay. From spring constant. So from the equation of a spring, we know F is equal to minus kx. So work done. dW is equal to F dx. Okay. Now what I will do, I will substitute F. So dW is equal to minus kx dx. I just substituted F. Now I integrate both the sides. So dW's integral is W is equal to integral of minus k I can take outside. Minus k I'll take outside. Integral of x dx. Integral of x dx is x square by 2. Okay. So x square by 2 I will take. X square by 2. So W is equal to minus k x square by 2. I have to apply my limits. X is the upper limit, 0 is the lower limit. Minimum is 0, maximum is x. So this will be W is equal to kx square by 2. Okay? Yeah? So I will get potential energy as half kx square. Half kx square or kx square by 2. Okay? Okay. Next question. State that the kinetic energy of an object on reaching the ground dropped from a certain height is equal to the gravitational potential energy at the initial height. So let's say there's a ball, okay, and it's dropped, okay. So at the top, the mechanical energy, and at the bottom, the mechanical energy, we have to prove that both are the same. What is mechanical energy? Kinetic energy plus potential energy. Mechanical energy is kinetic energy plus potential energy. So we have to prove that mechanical energy on the top and the bottom are the same. So here what is it? At the top, potential energy is very high, mgh. Kinetic energy is 0 equals to. At the bottom what happens? Potential energy, all of the potential energy gets converted into kinetic energy. So it becomes 0 plus half mv square. Now when you equate it, what will you get? mgh is equal to half mv square. M and M cancels. So gh is equal to v square by 2. From that we will get v is equal to square root of 2gh. Okay. So what's happening? So initially the ball is at a height. So at that time potential energy is very high, kinetic energy is 0. Then it is dropped. When it is dropped, during its journey, all the potential energy gets converted into kinetic energy. Okay. Here? Very good. Let's look at the next question. State and prove the law of conservation of mechanical energy. So what does this say? The total mechanical energy. What do you mean by total mechanical energy? Sum of kinetic energy plus potential energy. We have to prove that it remains constant. So we are going to use some theorems that we already learned for this one. First theorem that we are going to use is work energy theorem. What does the work energy theorem say? W is equal to delta kinetic energy, which is K final minus K initial. Okay. Another thing that we already learned is for conservative force, work done is always minus potential energy. Okay, students, so some of you might be wondering here how work done became. See, work done is minus kx square. When it comes to potential energy, you just take the positive. Okay, that is because work done is negative of potential energy. I forgot to tell that here. Yeah. Okay. Okay. So this is the statement that we're using there also in that question. What we're using is work done equals negative change in potential energy. Okay. So I just wrote W equals minus kx square by 2 there, simply to positive potential energy. Okay. Yeah. Continuing this one. Okay. So work done is equal to minus U, which is minus change in potential energy, which is minus P final minus P initial. Okay. Now both are work done, so let's equate it. So K final minus K initial is equal to minus P final minus into minus plus P initial. Now I'll take it to the other side. K final plus P final is equal to K initial plus P initial. Hence proved total mechanical energy is conserved. Mechanical energy final is equal to mechanical energy initial. Proved. Hence proved. Okay? Yes. Are we all here in class? Yes. Hmm? Okay. Shall we move on? Okay. Next question. A force F is equal to 5i cap plus 3j cap plus 2k cap is applied. Over a particle which displaces from its origin to the point R, 2i cap minus j cap. Calculate the work done on the particle. So what is the formula for work done? Work done is force into displacement. What is force? 5i cap plus 3j cap plus 2j cap. So I'll multiply the I cap terms. Okay. So 5 and 2 I'll multiply. 3 and 1 I'll multiply. 2 and 0 I'll multiply. So 5 and 2, 3 and 1, 2 and 0. So what do I get? 10 minus 3, which is 7 joules. Very easy. No? Okay. Okay. Next question. A man pushes a roller coaster with a force of 50 newtons. He pushes it for a distance of 20 meters. Calculate the work done if the handle of the roller is inclined at an angle of 600. No, this is not 600. This is definitely 60 degree. Okay. You can't get 600 degree. So there's a mistake in the question. Not a mistake. It's just a typo. 60 degree. Okay. So how will you find work done? FD cos theta or FX cos theta. Fx cos theta. So this is 50 times 20 times cos 60. 50 into 20 into 0.5, you should get 500 joules. Okay. We just have 2 more chapters. Okay. System of particles and gravitation. Okay. 2 more chapters. And we are done with all the 3 markers of this chapter. Okay. Next question. System of particles and rotational motion. First question. Write 3 kinematic equations of rotational motion of a body with uniform angular acceleration and explain the terms. Students, this is very easy. Okay, I'll teach you a trick to do this. So we know first equation of motion is what? V is equal to U plus AT. That we've already learned. Yeah. V is linear velocity. So I have to convert V into angular velocity omega is equal to U is what? U is omega naught. Yeah. Initial angular velocity is omega naught plus acceleration becomes what? Acceleration becomes angular acceleration is alpha. Linear acceleration is A. Angular acceleration is alpha. So alpha t. That's all that you have to do. Okay, so you have to remember instead of V, you write omega. Instead of U, you write omega naught. Instead of acceleration, you write alpha. Okay? Yeah? Is that all right? Next. Next is x is equal to ut plus half at square. So instead of x, I will write theta. Okay? Theta is equal to, instead of ut, I will write omega naught t plus half. Instead of alpha a, I'll write alpha t square. Okay? Next is what? V square is equal to u square plus 2ax. So let's do that. V is what? Omega. U is what? Omega naught square plus 2. Instead of acceleration, I'll put alpha. Instead of displacement, I'll put theta. Okay? Very easy. You just have to relate and study. Relate linear ones to this one and study. Okay? I didn't eat dinner. I will eat after class. Okay, Shivu, did you eat? Yeah? I am from Kerala. Right now, I live in Bangalore. Okay? Yeah. What is the rotational analog for the equation dw equals f dx? Prove that p is equal to tau omega. Okay? So we have to prove that dw is equal to tau omega. So let's first write down what we know. We know that work done is what? Force into displacement. This we know. Now we'll write it in terms of rotational motion. dw will be the same, is equal to force will be tau. Displacement is theta. So instead of dx, it will be d theta. Okay? Now, power is what? Power is dw by dt, which is tau d theta by dt. Okay? Now, what is displacement by time? Generally, yeah, displacement by time is velocity. So, angular displacement by time is angular velocity. So, this will be angular velocity. Okay? So, if you relate and study like this, it's going to be very easy. This chapter is the easiest. Okay? But you have to relate and study. Okay? Yeah. Next question. What is the relation between angular momentum and moment of inertia? Prove that torque is equal to I alpha. So I already taught you in the last class. Angular momentum is I omega. Already taught that. Yeah. Now let's do some differentiation. Okay. So when you differentiate it, you will get torque is equal to dl by dt, which is I times dw by dt, which is I. Dw by dt is what? Change in angular velocity by time. So it will be alpha. Okay. Okay. Next question. Distinguish between vector product and scalar product. Very easy. Vector product is what? A cross B. Scalar product is A dot B. A cross B is AB sin theta, A dot B is AB cos theta. Here the answer will have direction, n cap, because it's a vector. Here the answer has no direction, so it's a scalar. Example, R cross Fn, F dot D. Very straightforward. Okay. Very straightforward. We've already discussed this. Okay. Next question. Explain the principle of moments for a lever. Okay. So the principle of moments just states that the sum of anti-clockwise moment is equal to the sum of clockwise moment. So force into displacement on one side will be equal to force into displacement on the other side. Anand Babu, hi Anand Babu. So to download notes, okay, what you need to do is you need to join the Vedantu Karnataka Telegram channel. Okay, so the link will be there in the description. So you have to join a Telegram channel. The notes are always uploaded in Telegram. Okay, or you can just go to Telegram, type Vedantu Karnataka, join the channel. We always upload our notes there. Okay, you can download PDFs from there. I hope I've answered your question. Okay. Next question. Obtain the relation between linear velocity and angular velocity of a rotating body. Already I explained to you this. Yeah. What is angular velocity? Change in velocity is displacement by time. So angular velocity is angular displacement by time. Okay. So the relationship is basically linear velocity into r gives angular. Okay. So V is equal to R into d theta by dt. So d theta by dt is omega. So V is equal to R omega. Okay. Okay. Next question. Derive the expression for kinetic energy of a rotating body. Consider, okay, we have to find out the kinetic energy for a rotating body. So what we'll do, we know kinetic energy is half mv square. Yeah, I know that kinetic energy is half mv square. So this I can write it as half m. Instead of v, I will write it as r omega. This we just derived. V is equal to r omega. Okay, so v, instead of v, I can write it as r omega. So this will be half m r square omega square. Okay. Now, if I take omega square outside, this will become m into r square, which is basically I. So this term is I. So I will get half into I omega square. Okay. So this will be half into I omega square. Now here everywhere I've taken it for I. Yeah. So if I want to take it for other j, k and all, I will take summation. Summation means I can take it for so many different terms. Okay. Thanks Shivu. So I want you to share this video with all your friends. Okay. Yeah. So that's the only thing that I want you to do. Share this with all your friends and hit a like. Give me a like. Okay. Let's have some likes for the video. Quickly like the video and share it to all your friends. I will be coming with more such content in next classes. Next question. Two particles of masses 2 kgs and 4 kgs are located at 2 meters and 4 meters respectively from the origin along x-axis. Find the coordinates. Center of mass, this is a formula. What is the formula? m1x1 plus m2x2 is equal to m1 plus x2. m1 plus m2. Direct substitution. What is the first mass? 2. First distance 2. Second mass 4. Second distance 4. Divided by m1 is 2, m2 is 4. You will just get the answer. Direct substitution. Okay? Yes? Okay. Next question. Find the torque of a force 2i cap minus 3j cap plus 4k cap above the origin. The force acts on a particle whose position vector is I plus j minus k. Okay. Let's do that. So what we're going to do is, since it's cross product, you write it as a matrix. So I'll show you how you do that. So first row will be I, j and k. Okay, first row will be I, j and k. Second row will be these terms. So no, it's R cross F. Okay, students, you have to be very careful about the order. So if it's R cross F, then second row will be R, third row will be F. So let's put the R terms. 1 I cap, 1 j cap, minus 1 k cap. Okay. Now, F terms, what are the F terms? 2, minus 3 and 4. Now, how are we going to solve it? How are we going to solve it? So what I'll do is, first I'll take I cap. Okay. For I cap, what I'll do is, I'll ignore the row and column that has I cap. And I'll take this matrix. Okay. So what I'll take is, I'll take the determinant of that matrix. 1, minus 1, minus 3 and 4. Okay. So my matrix that I'm going to take is 1, minus 1, minus 3 and 4. So what I'll do, I'll cross multiply. So 1 into 4 minus 1 into minus 3 with an I cap. That's the first term. Now, second term is always minus. Okay. Minus j cap. Second term is always minus j cap. Okay. Minus j cap into, which is my matrix. I'll ignore the row and column that has j cap. Okay. So, what will my matrix be now? 1, minus 1, 2 and 4. This will be my matrix. I have to ignore the row and column that has j cap. So this will be my matrix. So again I will do 1 into 4 minus 2 into minus 1. Next, k cap is always plus. So I cap minus j cap plus k cap. So for k cap, which row and column should I take? I should ignore the row and column which has k. So I'll ignore this and this. So this will be my matrix. 1, 1, 2, minus 3. Okay. So it will be 1 into minus 3 minus 1 into 2 into k cap. Okay. And then I will just solve the brackets. I'll get the answers. Directly I'll get the answers. I just wanted to write the first one, first 2, 3, so you understand. Okay. Yes. So what you should do, write it as a matrix to first get the I cap. The row and column with I cap you ignore. The rest you take as a matrix. Then for j cap, the row and column with j cap you ignore. The rest you take as a matrix. For k cap, the row and column with k cap you ignore. You take that as a matrix. So right now what I have drawn is for j cap. I'll draw for k cap also and show you. Not working. Okay, for k cap it will be this and this. Those two I'll have to ignore. Okay, next question. A meter stick is balanced on a knife edge at its center. When two coins, each of mass 5 grams, are put on the top of the other at 12 centimeter mark, the stick is found to be balanced at 45 centimeter. What is the mass of the meter stick? Okay. 2, 5. I'll tell Baswaraj sir, okay? I'll tell Baswaraj sir that Shivu said he's the best biology teacher, okay? Alright. So there's a meter stick, okay? It is balanced on a knife edge, okay, at its center. When two coins are put on the top of the other at 12 centimeter mark. Okay, so there are two coins put at 12 centimeter. The stick is balanced at 45 centimeter. What is the mass of the stick is the question. Okay, which means mass into 5 centimeter. Yeah. So mass of the stick into 5 centimeter will be equal to how many masses are there? 2 into 5 into 45 minus 12, the extra length. So when you solve it, you will directly get mass. Okay. With that, we come to an end of this set. Last chapter, gravitation. First question. State Kepler's law of planetary motion. First law is the law of orbit. Every planet moves around the sun in an elliptical orbit with sun as the focus. So sun is the focus. The planets move around it in an elliptical orbit. Okay. Now, a line joining the planet and the sun sweeps out equal areas in equal intervals of time. So here, if this much is the area, when the planet reaches here, this area is still the same. When the planet reaches here, this area is still the same. Okay. Every time the area between the sun and the planet is the same. Next is t square is proportional to r cube. What does that mean? The square of the time period of revolution of a planet is proportional to the cube of the semi-major axis of the orbit. Okay. Yeah. Okay. Next question. Derive, this question can be asked in different forms. It can be either asked to derive the relationship between G and capital G, or it can be asked to derive the expression for acceleration due to gravity at a point on the surface. So what you will do, first you will write down the formula for force. Newton's law, F is equal to ma. Here acceleration is only because of gravity, so you write it as mg. Now Newton's law of gravitation, we already know F is equal to gmm by r square. Yeah. Now you just equate the two. So you just say this is equal to this, and you'll cancel m and m. You'll get the formula. Okay. Yeah. Very easy. You guys will kill me for saying easy, no? For me, every question is easy, you'll say. See, Vishivu, you can attend one of Baswaraj sir's class and tell him directly. Okay, I'll also tell him, but you also tell him. Okay. Yeah. Next question. Assuming the expression for orbital velocity of a satellite at a height h, derive an expression for its time period. So we already have learned in the chapter that the formula for velocity is v is equal to square root of gm divided by r plus h. Yes, and what is time period? Time period is 2 pi times the radius divided by velocity. And then you just substitute time period. So this velocity, you give this, and then you will get the answer. I want all of you to try this out and let me know if you're getting it. Simple substitution. Okay? Okay. Next question. Question number 4. The acceleration due to gravity on moon is 1.7. Gm is 1.7. And radius is 0.27 times the radius of the earth. So Rm is 0.27 times Re. You have to calculate the ratio. Okay? So we already know gravity is m by r square. Yeah. So Ge will be me by r square and Gm will be mm by rm square. And then you just equate it, substitute. Okay. What did I do? I just wrote it as me divided by mm into rm will go up. Yeah. Rm will go up divided by re square. Okay. All the values are there. You just have to substitute it. Okay. Next question. Mass of the earth is 80 times mass of the moon. Mass of the earth is 80 times mass of the moon. Radius of the earth is 4 times the radius of the moon. Okay. Acceleration is 9.8. We have to calculate the value of g on the moon. So we know g is equal to gm by r square. Again, you take the ratio, you find out g. You will get ge by gm is equal to 5 when you take the ratio. From this, we have to find gm. So what will we do? We will do ge by 5. Ge we already know gravity on the earth is 9.8. So 9.8 by 5. Okay. Fine. Yes. The escape velocity on Earth is 11.2 kilometers per second. Find the escape velocity on a planet whose radius is 2 times that of the Earth and mass is 3 times that of the Earth. Okay? So I just have to modify the equation. So velocity is equal to square root of 2g mp by re. Okay? Now what I'll modify it into? I'll write it as square root of 2g. Instead of mass on the planet, I'll write it as 3 times mass of the Earth. Divided by, instead of radius of the planet, I'll write 2 times radius of the Earth. And then I'll just solve it. Okay. Now, here, 2g, me and re together forms VE. So, I can write this as square root of 3 into VE directly. And then VE's formula value is given. So, I just get the answer. Okay. Okay, next question. A Saturn year is 29.5 times Earth year. How far is Saturn from Sun if Earth is 1.5 into, this is 10 raised to 8 kilometers from the Sun? What is Kepler's law? T square is proportional to R cube. So, Ts by Re should be equal to Rs by Re. This is cube. This is square. Now you just cross multiply. Ts square is equal to Rs. So in the question it says that Ts is equal to 2.95 RTE. Okay. So you can write Ts as 29.5 TE by TE. This is T by TE is equal to Rs by Re. This is cube. This is square. TE cancel. That's how I get this. So I'll get 29.5 square is equal to Rs by Re cube. Okay. Rest is very easy. Mathematics. That you can do. Alright. Okay, I think this is 2 more questions. An Earth satellite in a circular orbit at a height of 200 km above the Earth's surface. If the radius of the Earth is 6,400, find the orbital velocity. Okay. So radius of the orbit is what? The radius is equal to radius of the Earth plus some height. So the total radius, if this is the radius of the Earth plus this height, this full thing is R. Re plus H. And that value I already have. So velocity I know, gm by r. So I can also write it as gre square by r. Okay. And then I get the answer. Okay. Next question. This is the last question. A rocket is fired from the Earth towards the Sun. At what distance from the Earth's center is the gravitational force on the rocket 0? Mass of the Sun is 2 into 10 raised to 30. 2 into 10 raised to 30. Mass of Earth is 2 into 10 raised to 24. Neglect the effect of other planets, all that is fine. So we already know what is the formula? Gm by r. Instead of distance, I put it as x. So this is for the Earth. So for the Sun, it will be r minus x, the whole square. Okay. Now what we'll do, g and g cancel and then I'll take the square root. I'll take square root on both the sides. So what will this become? Square root of me by x is equal to square root of ms by r minus x. And then you cross multiply to get x. Okay. Why did I take square root? Because here there's a square. Okay. Not here. No. Here. For x there's a square. Okay. So to ignore that square, I took a square root everywhere. Alright. Okay. So with that, we come to an end of 3 markers from for your midterm. All the chapters, all important 3 markers I have discussed. Okay. So I'll come with the next video, which will be probably 5 markers. We already did a video on 2 markers. So please do go check out that video as well for 2 markers. Do this for 3 markers. And I will come with more videos to help you for your midterm. So together, let's crack your midterm. Okay. I want all of you to score out in your midterm. All the best, students. So if you've liked the class, please let me know in the comments and like the video, subscribe, share it to all your friends.